In this video, we'll discuss code splitting, which allows us to produce on-demand code bundles for optimally loading code when needed. We'll use React.lazy and the suspense component in this process. Let's begin. React apps are made up of components and assets spread across multiple files. You often have third-party packages and modules that are used too. When using the Create React app or a similar toolchain, you need to produce a production build at the end to deploy your app on the server. This build process consolidates your code into bundles. So if your components and dependencies are spread across 5 files, they'll all be consolidated together into fewer bundles. Besides this, third-party code is also bundled together. The idea is to produce a minimal set of files which can be downloaded together in an optimized way. Now, as your application grows and evolves and the number of components increase, the size of your bundle grows too. Typically, all components imported using an import statement get folded into a single bundle. This can delay execution of your app if the client is on a slow connection, such as a slow 3G or a sketchy 4G in a basement, because the bundle needs to download to your browser before it is executed. With hundreds of components, this problem becomes critical as the size of the bundle gets pretty massive, even though you may not be using most of the components from the get-go. This is where you need to split your code into multiple bundles and load them on demand as and when they're needed. We normally use a static import statement to bring our components and code in. However, this tends to load everything before the execution begins. A draft ECMAScript proposal called dynamic import aims to solve this problem. Instead of the import statement, we can use the dynamic import expression whenever we want to load code from a file. This returns a promise which resolves with the code. Module bundlers and compilers like Webpack and Babel, which also form part of the toolchain when using Create React app, offer support for dynamic import. When a module is imported using the import expression, Webpack will not fold its code into a common bundle, but will produce an extra file or chunk which will be loaded only when needed. This means your initial bundle size won't be as big because a lot of code will be loaded on demand when called. In React, we can use dynamic imports along with the built-in lazy function to delay loading a component until it is required to render. And since there will be a brief delay as the component code is fetched over the network, we need to display a UI while the component loads in. This is where the suspense component comes into the picture. Suspense allows us to display a fallback UI while the component loads up from the network. Suspense is part of a much bigger framework of features that promises to optimize and deliver a fantastic user experience. It is important to understand here that we are talking about lazy loading component code only and not delays or time taken to fetch data from APIs and services within those components. Imagine a large-scale app that has to download hundreds of components. With code splitting and lazy loading components, the user experience is greatly enhanced since a minimal amount of code gets downloaded for the app to begin execution. Thereafter, components are downloaded as and when they are needed and are then cached. To understand all this, let's work through a project. Begin by downloading and setting up the project first and kickstart the development server. Our demo app imports 2 components, photos and posts, each of which load a set of images and data from an API to display. Our app uses a state variable named showContent to display these 2 components when the show content button is pressed. The first thing I'll do is create a production build to show you how Webpack will package this app. So we'll terminate our dev server and I'll run npm run build. This takes a while and produces a folder called build, which has the final optimized build for this app. If you peek inside the JS folder inside the static folder here, you can see our bundles and chunks that Webpack has produced. The first chunk file that begins with a number is typically vendor code or code that you import from node_modules. So React, React DOM, and other required code all sits inside this file. The chunk beginning with the word main is our application code and all associated files. So typically, if your app has hundreds of components, all of them go here in one massive file. Lastly, you can see the runtime file, which has the code that is needed to load your app in the browser. So let's implement code splitting so that we can hive off the photo and posts components into their own on-demand chunks which are brought in only when they're needed. For this purpose, I'll import the lazy function and the suspense component from the React library. First up, let's comment out these import statements. Then using a const named photos, I'll invoke the lazy function and we'll pass in a function which expects a promise which should resolve to a module with the default export containing a React component. We'll thus use the dynamic import expression to load the photos component because dynamic import expressions return a promise which resolve to the module. I'll do the same thing for the posts component as well. This equips our app to lazily load these two components only when they're required to render. Next, we'll wrap our photos component into an instance of the suspense component, and for its fallback prop, we'll set an h1 which says loading. We are thus asking React to display the words loading while the code from the photos component is being imported in. I'll repeat the same thing for the posts component too. Now, for all practical purposes, this is all you need to do. But our demo doesn't show any difference purely because we are loading two simple components and not 2000, and we are doing it locally on our machine. Thus, there is hardly any latency and our components load up instantly. So let's throw in a contrived delay into the equation. Since the lazy function here expects a promise, we can perhaps artificially delay this promise to simulate latency. So purely for the purposes of this demo, and this should never be done in production, we'll write a function called slow load. This function should accept a module using an import expression along with the duration in milliseconds, and it should return a promise which resolves with the import expression after the preset time has elapsed. Once again, this is neither a React feature nor this should ever be done in production. I've made this function purely to simulate network latency when loading a lot of components over a slow network. Then back in our app.js, we'll bring in slow load and I'll simply wrap our import expression in an invocation of the slow load function. And we'll wait for 1.6 seconds for the photos component to load and perhaps 800 milliseconds for the posts component to load. So now when we hit show content, you can see two instances of loading while the content is loaded asynchronously in the background. Once the component code is available, it is rendered right away. This means the rendering of your page was not blocked due to a massive app bundle. Our app started rendering with the minimal amount of code, and when needed, we brought in components asynchronously, and we also displayed fallback text to indicate that a component is currently loading. To sweeten the deal, we've also included an animated spinner component among the files, so I'll import it in first. And then we'll just use that as a fallback component. You can now see a red spinning graphic while your components load up. And here's something interesting. Instead of two suspense components, you can also encapsulate both the photos and the posts components into a single instance of suspense. The suspense component then monitors both components, and only when both are available does it render them together. Isn't that amazing? As a final step, let's produce a production build to see if code splitting has produced a change or not. You can now see chunk number 2 with the usual React code, but we've got two more chunks now, marked 3 and 4 in their file names. Number 3 is our photos component and its dependencies, which was a simple function that returns a static array of photo URLs and titles which are also bundled here. Number 4 on the other hand is our posts component and its dependencies. These new chunks were previously folded into our main chunk file, the size of which has gone down as a result of code splitting. As you saw in this example, code splitting helps to bring down the size of code which is loaded initially to bootstrap and execute the app in the browser. React's lazy function coupled with dynamic imports and the suspense component help you lazy load components on demand, and to ensure a superlative performance, the suspense component allows you to render a fallback UI while your component code is brought in from the network. Do note again that we are strictly talking about loading component code and not data loading latencies as a result of API calls within components. React is on the verge of offering concurrent mode in the stable edition, which will bring the power of suspense to data fetching as well, thereby enabling you to display fallback UIs while your data and components load asynchronously without blocking the render. Now, coming back to our subject, let's see how we can lazy load components when using the React router in the next video.